Hi students, welcome to my course module on process plant operator training using a simulator. Hope you have gone through my earlier videos, otherwise it is difficult for you to understand the process. As we are going through the controllers and we have discussed about the ratio control, especially to maintain the ratio. Today we are going to see the operation of a single CSTR. Then what are the different control systems involved as far as CSTR comes in play. Like the way we have discussed in the distillation columns, let us go to the simulation mode and make us comfortable with the CSTR. This is what the CSTR looks like. As you can see on the screen, and presently you can see the CSTR, and there is a jacket to which will supply the blue line, which is a cooling water, because an exothermic reaction is going inside. There is a stirrer attached to a vessel which makes it a CSTR. You can turn on and off the stirrer. You can see how many controllers are involved. And the objective is to maintain, get some reaction and to increase the conversion percentage. As you can see at the process value, you can see presently for this present conditions, the conversion is reaching around 72.39%. And what are there are many controllers are as such involved. One such is on the left side of the screen, a reactant B going into the reactor, and from the right side reactant A are going into the reactor. Both are getting reacted to form a product, and from the bottom of the reactor we are drawing the product stream through the particular valve. See how many controllers are involved. The first controller that comes in play is called a ratio controller. Ratio controller, as we have discussed in the ratio control video, it does the job of maintaining the particular ratio of A to B, and presently it is 2. As you can observe, there is a 5 tons per hour of A is going inside, and accordingly 10 tons of B is going from this particular line and mixing in the particular reactor. The job of this controlling the ratio of A to B is done by this RC ratio controller. And this is one manual indicating valve, because here using this valve you can able to control the mass flow rate of A into the particular reactor. Presently it is 8.6% open. This is a manual control valve. We have to use manually you have to open the valve. And this is the on one side, because it's exothermic reaction, a cooling water is going to supply through the jacket, and the cooling water flow rate to the reactor is controlled by the temperature inside the reactor. Presently the temperature inside the reactor is 50 degrees centigrade, and we also have to maintain the reactor temperature is a 50 degrees centigrade. And the entering temperature is 38.82 degrees centigrade, and once you can see because of some exothermic reaction, the exit presently the reactor temperature inside the vessel is 50 degrees centigrade. 50 degrees centigrade because an exothermic reaction is going on. Presently, if you click this controller, presently the cooling water supply set value is 50 degrees centigrade. To maintain this 50 degrees centigrade inside the reactor, the valve has to open around 52.25%. This you can see Fi004 indicates how much amount of cooling water that is going into the jacket. Currently 25 tons per hour of cooling water is going into the jacket, and it is simple feedback control system. Here to control the temperature, cooling water flow is through the simple. It will measure the temperature, then it sends a signal. It measures sensing element measure the temperature. Accordingly the controller will send a signal to the valve to maintain the how much amount of flow that has to be flow into the particular reactor. This is simple feedback, and this is also feedback control system. See, we also have to maintain some level in the reactor. Presently the level has to be the 50% level you have to maintain in the reactor, so it senses the level. Accordingly it will give the signal to the particular valve, so that if valve will open according to the level in the reactor. Presently 50% is the level, process value is also 50%, set value is also 50%, so manipulated variable is around 51.57%. So what we can do with this is, it's a design start, because everything happens at the steady state. Now what I can do is we have to observe what is the job of a ratio control is to change the amount of B according to the A. Always the ratio control job is to maintain the A to B ratio, B to A ratio, which is 2. Always it has to maintain this stoichiometric proportion. according the ratio control which does the job. What happens presently, you can see 5 tons per A and 10 tons per B. The ratio is 2. So what happens the moment I change this manual control valve position, even let us say if I increase this valve position, what happens? Accordingly, if you increase the valve position, the amount of A going into the reactor will get affected. So that what is the job of a ratio control is to change the valve position of B so that ratio is 2. B to A it should be 2. And that is what, and accordingly you can see if you pump more amount of things into reactor, automatically the process value presently will drop down because more amount of coming into the reactor. So it will take, I mean, if more amount of coming inside the reactor, automatically the temperature will drop. Automatically, if the temperature drops, the valve position, because this controller will send a signal to the valve to supply more amount of the cooling water into the reactor. Because if a more exothermic reaction is going to take place, a more exothermic reaction is going to take place, accordingly it will the process value will be increased, accordingly the cooling supply also going to increase. So let us see what happens. Presently everything is on and you can turn on and off the stirrer. You can see you can turn off the stirrer. Okay, model is in hold position. Let me turn on the model, run the model. So now we will observe, now it is on, I can make it off. Okay, now stirrer is off. So let us not worry about the stirrer at this moment. Just turn the stirrer on. So this color indicates the turning on the stirrer. Okay. There is one reset button. If something beyond the limits are happening inside the reactor, automatically the reactor will turn off. This particular stirrer will go off. So let us open what your job is to observe the different parameters. Once I change the valve position, what happens? You can see how my conversion is getting affected once I open this particular valve. So if you open the valve to the higher position, what happens? The more amount of fluid that is going to come in. If more amount of fluid going to come in, automatically it affects the space time. So according to the space time, how my conversion is going to be affected. If by increasing the space time, what is happening? If you're decreasing my space time, what is happening? So if I reduce my flow rate by keeping the same volume, okay, what happens? If you reduce the flow rate by maintaining the same volume inside the reactor, of course you are going to increase the space time. Once your space time of the reactants are increasing in this particular vessel, automatically the conversion is going to rise. These are the things you have to observe. Okay, let us increase the flow rate to the reactor. See, now the moment I open this valve, automatically it will sense a signal. The process value and set value are different. Accordingly, it will send a signal to the particular value. Okay, let me increase the valve position. Let us presently at 46, manipulator variable is 48.6%. I will change it to 60. See, the ratio now get affected. See, the process value and set value are different now because I have affected the ratio. So accordingly, it will send a signal to make sure the ratio is 2. That is process value and set value equal to 2. And what happens inside the reactor? So more amount of reactants are put in, automatically the temperature got raised because it's an exothermic reaction. The more amount of A and B is participating in the reaction, the temperature is going to raise. Automatically it will send a signal to the valve. Automatically the flow has to be raised. You can see 25.28, 25.29. The cooling water supply to the reactor is getting high. What happens to my conversion? You can see initially the conversion seems to be rising because you can see the level. So the level has been raised. That means it is indirectly affects the space time also. So see the dynamics. Now it is increasing, but after some time, see what happens. Whether it is still increasing or trying to decrease. There are a number of things happens because you are affecting the space time, you are affecting the flow rate. So during that dynamic period, the moment you open the valve, many things happens in the reactor. So what is the first thing that is happening? You can see, the conversion seems to be rising because more amount of flow, even though you because you have increased the flow rate, right? If you increase the flow rate, what happens? Okay, automatically the space time has to be reduced. If the more amount of flow, that means less amount of the space time. If less amount of space time, less is the conversion. But up, you will observe the conversion seems to be rising. Why it is happening? Even though if you increase the flow rate, the conversion is rising here because See, the level is increasing. If the level increases, the volume is increasing. The volume is increasing. Volume by volumetric flow rate is my space time. Of course, that means in the initial period, because of the increasing volume, the conversion space time you have increased. The conversion seems to be increasing. Once the level indicator trying to reduce the volume to the same level, that means what is the job of the level indicator is to maintain the level to the 50%. Once it comes to the 50% level, that means you have increased the space time. Volume remains the same, but you have increased the space time. So automatically see what conversion is going to get affected. So these are the different things. Observe the cooling water requirement. Observe the cooling water entering temperature, which is around 25 degrees centigrade. The cooling water exit temperature is at 46.17. Presently the conversion is 76.57. Now you observe the conversion starts dropping. Okay, initially it starts rising. Once after period of time it starts dropping. Why? Because you see the level is getting down, because the moment you put more amount of the reactants into the reactor, the level has been raised, the volume has been increased. If you increase the volume of the reactor, of course the conversion is going to rise at the initial time. But what happens with the time, the level indicator will try to increase the exit flow. Now this level starts to reduce. That means now the level slowly come to the 50%. That means the set value is 50%. The level come to the. That means what happens after some infinite time, the level is only 50%. What you have increased the flow rate into the reactor. Of course, the conversion is going to get down if you increase the flow rate into the system, because you have space time has been reduced. If the space time has been reduced, automatically the conversion is going to get reduced. That is what the job. See, now the dynamics 90. Initially it was rising, now it is dropping. So these are the dynamics you all have to understand, because if you, even though you play with this particular system, what is going to be get affected at the ultimate. See, let me increase the let me increase the simulation speed, okay, 10 times. What happens? You see the conversion is dropping. Finally it will reach to a stable point. Let us see what is that stable point. Now what is the design value? Design value of the conversion, something around the 72. The present value is 69. That means the conversion has been decreased because you have increased the flow rate into the reactor. For the same volume, if you increase the flow rate, the conversion will low. So hope you have understood the reactor. Main important in the industry, not everything happens in the steady state, because there might be some disturbance coming into a reactor. How the entire system will reacting to that particular disturbance, because we have increased the flow rate. Similarly, if you decrease the flow rate, what is going to happen once you do the hands-on on this particular software, you'll get to learn many things. Okay. Hope you understand what is CSTR. We will meet up with the another video of CSTR, maybe 2 CSTRs in series kind of thing. We can know to get a more information. I hope you are enjoying the videos, and thank you very much. This is Dr. Surya Prasad.